Hello everyone, my name is Disha and welcome to my session. Today we are going to talk about statistics. Actually, what is statistics? Why we are talking about statistics? What are the different applications of statistics? Why this statistic is playing a very important role nowadays? These are things we are going to learn today. So here, what actually we are going to cover in today's session, we will understand like what is statistics, why we are using statistics. Then there are different types of data. We will talk about them. And then we will talk about descriptive statistics. Like under that, we are having measure of central tendency and measure of dispersion. And finally, we will do some implementation, some coding, right? Okay, so let's move. So first of all, let's understand like what is statistics. So you must have heard like what is statistics, why statistics is playing a important role in data science field. Not only in data science field, like in most of the fields, if I talk about. So statistics is very important. So basically, what is statistics? Statistics is a branch of mathematics which is dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. So we are having huge data nowadays. Nowadays, a lot of data is available on which we can do some sort of analysis. So first of all, what we actually do, we collect the data and then we start some kind of analysis. And then we do some coding, some interpretation out of our visualization, like what actually the data wants to uh, conclude, like what we can conclude from the data, right? So it deals with the data collection, organization, analysis, interpretation, and finally the presentation. Because without presentation, without visualization, our perspective, our what actually we want to conclude from the data, it's very important to visualize it, because from the visualization only we can complete our research process. Okay, so through the visualization, actually, we can easily put our insights, like what actually the data wants to say. Okay, so if I take a very simple example of corona vaccine, so what happened actually, they didn't directly launch that corona vaccine to the market, to the population. What they did actually, they did some research on that. So they first finalized like this vaccine actually going to work on the population, but directly they cannot put that vaccine on complete population. So what they did, they worked on the sample. Okay, so why I'm using these terms like population, sample? So these are very important key terms of statistics. We are going to understand that also. Let's move. Why statistics are important? So when we are talking about like we want to take out some conclusion out of our data. So first of all, we will try to analyze the data. We will try to analyze the things, the data which we are having with us using some mathematical formulas. Okay, so we will use like standard tendencies, standard deviations, central tendencies. There are a lot of statistical terms which we are going to use to analyze our data. Okay, then it will help us to keep us informed about what is happening in the world around us. Okay, the third one, we live in the information world, and much of these informations are determined mathematically by statistics help. Okay, so we actually through this session we will understand like why statistics we are using. So even you, if you will pick up any article, any news article, there also, if they have in the research part, if they have done kind of research, so in the through the news article, what you can do, you can see, you can see that they must have used statistical terms like variables, standard deviation, average, arithmetic mean, statistics, parameters, a lot of key terms they must have used. So I'm going to tell you like what these key terms means actually. Okay. Now applications. So application of statistics, like I told you, like statistics is playing very important role. So there are a lot of fields where we are using statistics. So you can see there's a list of like business and economics field is there where we are using this statistics. So business is basically using the statistical models to focus the demand, like set prices, optimize operations. Okay, so they are using this statistic. Now second is medicine and healthcare. So there also we are using statistical methods, statistical models. Now third one, social science. So statistics actually help us to analyze survey data and public opinion about anything. Okay. Third and the fourth is engineering, where we want to do or we want to analyze the data from some experiments. So there also we are using the statistics. If I'll talk about the environment science and sports and many more other fields are there, we are using the statistics. Okay. Now statistics terminology. So statistics terminology. So I just spoke in the last slide, like there are key terms: population, sample, standard deviation, variance, dispersion, center tendencies. A lot of key terms are there. So one by one, we are going to understand these all things. So let's understand first of all what is population and what is sample. So let me take a very simple example. Let's say that I want to find out the average height of a city of the person. Definitely, I'm talking about height. So definitely, I'm going to measure the height of all population in that city. But I want to find out the average. Okay, so will because I that city population is very high. So what I'll do? Will I measure the height of each person? Is it easy? Actually, no, it's not easy. So what we do actually, we work on sample. Okay, let me take another example. If I'll say that the 8th class standard students are there, I want to find out like what is the average height of this class. So in a class, around 30 to 40 students are there and of same age, 8th standard, same age. So height would be around, right? What I'll do, out of 40, I'll take out 20 students and I'll measure the height. Okay, and simply I'll find out the average of that height. And now I can say the average height of the 8th standard is this one. Okay, so without experimenting on whole population, what can we do? We can simply collect the sample and then we will try to inference the population. So don't get confused, guys. These are some basic examples. Okay, we are going to elaborate more, like how we are going to work on the sample, how we will take out the sample out of the population, and we will also understand like that sample which we are taking out from the population, will that sample actually represent the whole population or not? The sample which we are choosing actually a representation, a good representation for that population? Yes or no, we will find out that also, right? So without going on that step for now, what we will discuss right now, we will discuss like what is population and what is sample. So basically population, the whole population. Okay, so a collection or set of individuals or objects or events whose properties are to be analyzed. Like we want to do some kind of research of an area, of a colony, of a city. Okay, like this. So you can see this is my whole population. Now the sample. So sample is a subset of population is called sample. So where a well-chosen sample will contain most of the information about a particular population parameter. See, there is one more key term, that is parameter. Okay, so we are going to choose a sample which actually containing the most of the information of that particular population. Only then that sample will be a good representative of my population. Okay, so sample is a subset of the population and population is the whole population. Okay, now let's move. So see one more, like this is my whole population. Let's say it's about a city or a colony, anything, any class like this. Okay, and now I'm choosing some random persons out of this population and collectively I'm keeping it in my sample. Okay, so there are a lot of sampling techniques actually which we use to take out the sample out of the population, like which sampling technique I want to use to take out the sample to do my research. Okay, we'll talk about that also. But for now, we will simply understand like what is population and what is sample. So sample is a subset of the population, and population the whole we are talking about, right? Let's move. Now you can see that there are types of data. So you must have heard in 8th or 9th standard also, there also we talked about some data. So data further divided into two parts. One is quantitative data and another is your qualitative data, right? So quantitative data means numerical data. So we will first of all keep in our mind one thing, that when we are talking about the quantitative data means we are talking about the numerical data, right? And when we are talking about the qualitative data means we are talking about the categorical data. So these two things we will keep in our mind, right guys? Now, quantitative data is further divided into two parts. So first is my discrete. This is my discrete data. And the second is my continuous data. So now what is this? Discrete data when I'm talking about the number, the whole number. Okay, let's say that the number of students in a class, or we can say the number of workers in a company, or we can say the number of home runs in a baseball game. Okay, when we are talking about the whole number, it comes under the discrete data. Let's say 1, 1, 2, 3, like this. Okay, if I'll say that like how many number of students are there in 8th class, so I'll say that it's 40. Okay, or if I'll say how many students are there in data science batch, so let's say it's 30. So can it be 30.5? No, definitely no, right? When we are counting, when we are doing some count, so that cannot be a integer float, right? It's so discrete is like we are talking about the whole number. Now continuous data. So continuous data, like simply if I'll talk about in the very simple term, so we'll talk about like floating number, float point number or floating point number. So let's say an example, the height of children, or we can say the square footage of 2-bedroom house, or we can say the speed of cars. Okay, so these all come under the continuous data. I hope we are clear with the discrete and the continuous. And if I say the height, so height is like height can be 6.5, height can be 5.6, right? If I say that the rainfall, how many inches it is going to be, so I'll say that 3.34, something like, okay. Or if I say that there is a range, or I'll say that 11 to 20, there is a range. I'm going to include each number which is coming into this range, means between 11 to 20. So I'm going to include each and every decimal point number. So that can also be 11.1, or it can be 11.99, or it can be 11.99999. So each decimal point is included in this range. But if I'll talk about the discrete, if I simply write 11 to 20, the same range in this discrete data, so it means it is including only the whole number like 11, 12, 13, 14, 15, and so on till 20. Right, guys? Okay, now let's move to the qualitative data. So in the qualitative data, further it is divided into two parts. One is ordinal data and the second one is the ordinal data. Sorry if I have mistaken. One is nominal data and another is ordinal data. Okay, nominal data is very, very basic, like when we are talking about some names. Okay, when we can categorize the data based on their names. Let's say the gender, when we are having man, woman, right? If I'll talk about hair color, like gray, black, brown, burgundy, these are naming we are giving. Okay, if I'll say that ethnicity, like Hispanic or Asian, So these are what? They all come in under the nominal data. Fine. Now, if I'll talk about the ordinal data. So ordinal data, like it is having nominal with it. So like it is but keeping some order in that. Let's say that first, second, and third. There is some order in that. Okay. If I'll talk about the grades like A, B, C. So A is the highest grade, then B, then C. Okay. If I'll talk about the salary, like low, medium, high. So there is a order. Okay. Now if I'll talk about the economic status, low, medium. So there is an order. So that's actually the difference between nominal and ordinal data. Fine, guys. So I'll clear the drawing. I hope it's clear. Like the types of data, there are two types: qualitative data, quantitative data. In the quantitative data, we are having discrete data and continuous data. And in the qualitative data, further two types: one is nominal data and another is ordinal data. Fine. Moving ahead. Now we are going to talk about descriptive statistics. So in that, the first part is measure of central tendency. So what is measure of central tendency? Let's understand it. Okay. So first of all, central tendency means we are talking about something around center. Okay. So there are three parts. First is mean, second is median, and third is mode. Okay. So whenever somebody asks about like what are the different kinds of measure of central tendencies, so these are the three: mean, median, and mode. So they all talk about some around center. Okay. So can you see this graph? So here it's mentioned like this vertical line is showing you the mean of this data. This vertical line is showing you the mode of this data, and this vertical line is exactly telling you about the median of this data. Okay, let's not understand what kind of data are we having here. For now, let's ignore it. We are just understanding these terms for now. Okay, so why actually we are finding out these mean, median, and mode? Okay, so let's understand the key points first of all. So the measures need to be based on all observations of data. All observations means, so let's understand it. So 1, 2, 3, 4, 5. So this is my data. I'm taking very basic, very simple example for now. So 1, 2, 3, 4, 5. So basically when we are finding out the measures of central tendency means we are trying to find out the one number summary. Just keep one thing in your mind, first of all, that we are trying to find out the one number summary of the data. Okay, so using these three types, we will get only one number output. Okay, so when I'll talk about like mean, if I'll find out the mean of this data, what it would be? It is going to include all the observations of this data. All the observations. All the observations means what is the formula of the mean then? Is the total of all observations. So total means 1 plus 2 plus 3 plus 4 plus 5, and then we will divide it by the number of observations. So how many observations do we have? So we are having 5. Okay, so what it will be? So 5 plus 4 is 9, and 10 and 15. It's 15. So answer would be 3. So mean of this data is 3. Now similarly, we will find out the median. Then what is median? This was actually mean. We got one number, right? That this is my mean of this data. Okay, now if I want to talk about the median, then median actually is a middle number, middle observation of the data. But when we are finding out the median, we have to sort the data. We have to sort the data either in ascending order or in descending order, right? So first of all, we will arrange it either in the ascending or in descending order. right? And then the middle number would be the median of my data. So here the median is 3. But again, there is a rule. The second rule for the median is that for the median, when we are finding out the median, we have to check like how many observations we are having in the data. Means it's even or it's odd. It's even or it's odd. Depending on that, we will find out the median, right? I'll show you that also. Now, if I'll talk about the mode is actually the most frequent value of the data. Most frequent value of the data. Let's say that in a shop, there is a number, shoe number, which is being sold more. More like that. The frequency of that shoe number is being sold is more. Okay. So let's say that the 7 number, shoe number 7, whose frequency is around 15. Around 15. But if I'll talk about the others, shoe numbers, it's less than 12 only. Okay, so the frequency for the shoe number 7, it's more, it's 15. So the mode of that shoe shop is 7, because 7 number shoe is being sold more. Okay, so what is mode? Mode is basically the most frequent data of that, most frequent observation. Okay, let's move. Okay, so now I told you like why we are using the measures of central tendency, but one question, just think and tell that can you use the measures of central tendency like mean, median, and mode to get the one number summary of all types of data in your data set? Just think for once. Okay, let me tell you here, but give a thought on it. Actually, no. See, when we are talking about the mean and median, means if we are having the numerical data, only then we can find out the mean and median. But mode we can use for both kind of data. Either it's numerical or it's categorical data, right, everybody? So give a thought on it, right? That like what is the difference between mean, median, and mode? Like why or when we can use these central tendencies, right? Now, so as I told you that what is the limitation of that? So is there any technique now that can be used to present a categorical type of data better? Means for the numerical, it's fine. We can use mean, median, even mode also, right? But is there any other way to present a categorical type of data better? So yes, there is. What is that? That is measures of dispersion. That is measures of dispersion. Okay, so that's the answer of this question. But we will not going to talk about the measure of dispersions right now. We will first understand the central tendencies. Okay, so here you can see that the mean, median, and mode. So mean is the calculated average, and the median, which is the middle value, and the mode where most occurring value, most frequent value of the data. Okay, so it describes the location of the data. The central tendency actually describes the location of the data, but it is failed to describe the shape of the data. Getting, guys? So using this mean, median, and mode, we are able to get one number about the data, right? But we are not keeping like what is the shape of the data, what kind of data we are having around that mean, that median, or mode. Then what is going to help us? For that, we are having that measure of dispersion. Okay. So now let me tell you first the formula of the mean, median, and mode, and then we will talk about the measures of dispersion, right? So here, mean, which is measure of average of all the values in a sample, is called mean. Average of all the values in a sample. So here, when we are finding out the mean, we are including all the observations, right? I have shown you previously that mean is including all the observations, right? So here, this is my mean. So you can see through this here, what is actually happening, that where it is giving us the information about the location, like it is the mean for this data, this is the mean for this data. For the blue one it's 1.5 and for this orange one it's 2.5. That's fine, but how it is spread out, like each observation is how much away from this mean, that we don't know, right? Correct. Okay, so median. So here median, basically median is what? Median is the measure of the central value of the sample set is called the median. Okay, so before finding out the median, we have to arrange our data in ascending or in descending order. Only then we can find out the mean. Okay, now one more rule that we will check out, like the number of observations in the data is odd or it's even, right? If it is odd, so to find the median, it's the formula that is n plus 1 by 2th observation. Otherwise, if n is even, then it would be n by 2th plus n by 2 plus 1th observation divided by 2. Okay, we will understand that also, no issue. Now, see, this is my data. So here, how many observations we are having? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17, like it's odd, right? 17 is an odd number. So what would be the middle? So this would be the median of my data set. This is the middle value. Okay, let's move. So this, the formula I have already shown you. Now, if it is even number, you can see here, if it is even number, then it is going to take out the mean average of both numbers. It will take out the average of both the numbers. It would be the median of this data set. Right, everybody? Okay. Okay, let's move. So here you can see the median would be 20 for this data set. Right? Now, mean versus mean. So as I told you that mean is taking all the observations of the data, but median is not. See, is median including all the observations? No, it is just keeping focus on the odd or even numbers and then taking out the median, the middle number only. It is not keeping in the mind like what kind of observations we are having in the left or in the right. Okay, but mean is including all the observations. So when mean is including all the observations, so definitely it is affected by the outlier. Okay, so here you can see mean is being affected by the outliers. Okay, why? Because when we are finding out the mean, let's say this is my data set. Okay, so when we will find out the mean of this data set, it's 4, right? Because see, these observations like 2, 3, 2, 3, 2, but suddenly we got a far away observation, which is very far away from these all observations, which can be treated as an outlier. Actually, which is affecting our mean. Okay, mean should be something around like in the middle, right? But it's not. Okay. Now the median for this data set. Median for this data set is 2.5, which is in the middle only. Okay. So keep in your mind, like actually mean is influenced by the outlier, not the median. Okay. So the median is much closer to most of the values in the series. But if we are having the outliers in our data set, so mean is mostly affected by it. Okay. We will keep it in our mind. Okay. The last one, that is a value most recurrent, most frequently used in the data set. It's known as the mode. Okay, so you can see in this data set the 16 number, which is being used 3 times. The frequency of this number is 3. If you will check like 10, it's only 2 times, 11, it's 1 time, 13, 15, 1 times, and rest all are also 1 time. But the 16 number, which is having the more frequency. Okay, the most frequent data, that is 16, right? Okay, so I'll talk till here only. The measure of central tendency is only. So what we actually discussed today, we discussed about like what is statistics, why we are using statistics. We learned about the different types of data. We discussed about the measure of central tendency, right? So Tomorrow means in the next session, we are going to discuss about the measure of dispersal, right? Okay. So for now, thank you so much. We'll see you in the next video. Thank you.